Maybe 11, yeah. Sounds all right. That's 68.
Are you, did you join the Zoom link?
I left it.
Okay,
Would
that's
you like
good.
me to re-enter and enter as my
Recording in progress.
Okay.
Good. I was like, you're good. Al's working. Everyone's good.
time.
You're gonna cover the performance on the bank. Inviting the dinner for sure. Have you ever met her?
Is it, did that thing just like move on its own to find?
That's what the owl does, based on who's. It does.
To
Oh,
Yeah.
Did she send?
It tracks the voices and moves the camera.
Oh,
around.
okay.
yeah, we're kind of around.
It's
no,
Data back.
I don't like drones and
Well, that's a drone.
I watched too much Terminator growing up.
Anyway, great. What about this faster in most cases? We were totally doing it on the ship.
Before we get started, we may want some swag, help yourself. We have some water bottles, hats.
Oh, look at that. Oh, and notebooks.
Yeah, grab some stuff.
Bigger notebooks.
Those are incentive for answering questions.
Yeah, grab some.
Thank you.
And then, if anybody doesn't have anything going on Friday, we are having a factory tour at in Poway. It's kind of like 35, 40 minutes from here. And you just have to email us by tomorrow. We got to clear you guys to go into the building.
Interested that I can attest that it's absolutely amazing to see how the looking surveyors you built. You get to see the little, ceramics, no photographs, they leave your phone at the front, but it's really neat to see the complex intricacies inside of it. And you can email us at RDI@teledyne.com if you want to come. We just need to know by 11:12 tomorrow.
When are you doing the tour?
Friday at 1.
Your traffic starts.
Oh, now, there you go.
No, it's usually not that bad from there coming back here.
Well, not back here. I'm going by.
Well, you'll be fine. Depends on where you're going though. How far you're going.
Close to LA. Oh.
Yeah,
No, I have I'm driving the 5.
every day is a roll of the dice.
Yeah.
I would say on the weekends, worst traffic is coming south.
The north.
On like Friday, Saturday, going south is the worst thing. I don't know if it's gonna be okay, but it's gonna be less bad than going south.
Think about it.
Should we start or should we wait for it?
But not very long. You got like 5 hours worth of information.
Yeah.
We're not gonna cover it all. We're gonna start.
Okay, Chris, you wanna go first?
Sure. Well, my shtick is usually to talk a lot. I'm not gonna do that this time. My other shtick is keep my mouth as shut as possible, which never works. So I'm gonna do my little spiel at the beginning. So Sarah and Chris and Paul at RDI Field Service and I cooperated to put the presentation, put the outline of the presentation together. These guys did all the work on the presentation. And then I went and reorganized it because we had 56 slides of packed with information. So we have compressed it down into the part where, in our experience, we have the most failures, which is the ocean surveyor. And that means that Sarah gets the short stick because she did all the work part and we're probably not even gonna get to it. But our two people are in the back who are here, Drew and Lauren. Wavy, wavy. Come on, there you go. And so, yeah, that's it. We're concentrating on errors in the ocean surveyors and how to diagnose what the problem is. Knock yourself out.
So I'm Paul, field service engineer for the last almost 3 years now at RDI. Lots of experience with buoy mounted ADCPs before. So we're gonna talk about troubleshooting at the instrument level, not tons of data stuff, just a little bit, but that's a little bit of troubleshooting. RDI's kind of started through scripts a bit back in 82. We're ADCPing. We have over 100 people. We make ADCPs and DVLs, which are the navigation side of ADCPs, and we've sold over 50,000. That's our office over in Poway. And these are kind of the three different types of vessel mounteds, the workhorses, the 300s. Most people in this group use 300s, or we don't have the Sentinel V up there because it's end of life. The ocean surveyors, the three different sizes, those are probably almost scale. The big 38 in the middle, and then the Pinnacle 45 kilohertz. And it's a direct read and a self-contained for moorings. This is kind of our general outline. We're looking at type of errors, acoustic, mechanical, electrical. For the ocean surveyor, what type of errors and how they get into the system, how to diagnose the errors. For the workhorse ADCPs, the design where errors can get in and diagnosing failures in the workhorse, contacting us and how to contact us and what to contact us. And another slide from Jules. So, type of errors you'll see are acoustic, mechanical, and electrical, and then we'll start moving on. So the type of errors, acoustic, you'll see other sonars. Right here we have an Ocean Surveyor 150, and I think this is from the Revell when I screwed up and sent them the wrong script file where they're supposed to do listen-only tests, and they collected tons of great data that it didn't do. We're actually outputting data pings here when we were supposed to only be listening so we could troubleshoot and see the pings and look for interference here. In this file from the UHDAS site, you can see noise and low percent good because of the Doppler speed log is close and the sound, and it's interfering with the workhorse 300. Other types of acoustic errors are environmental data. Waves and storms up here, you were seeing lack of signal strength, low percent good up at the top, and you see some data. And then you see really bad percent good because the weather is probably terrible and nobody's happy about working at sea at that point. Lack of scattering material. So we have another two examples of data here. The same ship for an ocean surveyor 38. They're real high latitude where there's no scattering and you have about 1,300 meters of range, but they go down to tropics near a submarine canyon where there's lots of sediment runoff and turbidity currents, and they're getting almost 1,800 meters of range on our ocean surveyor in narrowband, which is awesome. And so it's the same ship, different locations, but better conditions. The other types of errors we call it mechanical. It's bubbles. It's not really, I mean, yeah, mechanical. The bubbles, it's kind of bubble sweep or from storms and things. Nothing we can really do about it. It's kind of like a ship hole design. Then the next one would be ringing, where we have biased beam velocities towards zero, and you're not getting any good velocities. So part of the way to deal with ringing is the well design, put dampening material, lack of isolation is make sure there's bushings, rubber. Don't collect data there. Use a smaller frequency ADCP. If you have the 38, you should probably have a 300 kilohertz with it because you're only going to have 3 bins of not as good data versus with the 300 kilohertz, you'll have a ton of bins, 25 bins of good 4 meter data. So, and another way is change the blanking distance to kind of get rid of that. But since you have a ship, you can put multiple ADCPs on it. So Another failure, mechanical failure would be transducer failure. The other types of errors, electrical, how you get EMI generators near the deck unit. I don't know why CRT monitors don't really have those anymore. The other power supplies, things, the acoustics, other electrical interference near the OS cable, this cable, you know, if you're overpowering it, you're inducting, even though things are shielded, you could be inducting electricity into the signals and changing the signals. So you can kind of see the differences, and in the bias at the end of the range, you can see it's changing the bias when the ship is changing directions, which is blue is the heading here. So you can see there's positive and negative velocities because of electrical signals into the system. The Workhorse 300 is also, you don't have a deck unit, you have they're pretty notorious for bad power supply, so that's way down there. So we're going to go to the Ocean Surveyor, other design where errors can get in, diagnosing failures. Some of the failures on Ocean Surveyor could be the urethane coating. You know, you could have a failure, a bubble of urethane shouldn't happen because it would fail quality inspections on the way out. But if you had biofouling growth in there, or somehow if you didn't have an acoustic window, and the urethane got stripped off or pressure washed off or sanded off or something. So there could be a failure inside the ceramic in the array. So you have these 4 traces on the board, and you can kind of see the waffle shape for the ceramic for the phased array. You have a burnt traces right there. So the ceramic array failed on that one. And that's, so you can see it's burnt there. The beamformer board, this is the beamformer inside the transducer. And there's only one board in there. We made a change in 2016, and we don't have a lot of beamformer board failures anymore. So if you have a much older transducer, we'll keep an eye on that. But since 2016, we've had a lot less. They're very uncommon. So you see the 4 capacitors here, and they're labeled for the serial number of that instrument. If it didn't have that, what you have what's called is a generic beamformer board, and it's a replaceable board, but you will lose a couple bins of range, and that's because we tune the beamformers specifically for each transducer, so you get the maximum range out of it. If you have one that doesn't have the serial numbers, then you just have a generic, and that's like a field replaceable, a spare. But since they're not failing as much, we're not everyone's carrying them on the ships or something. The thermistor can fail, or it could be a sign of other things. The thermistor is this little tiny twisted pair that goes down through the center. It is embedded into the bell housing, into the ceramic, so you can you can tell the temperature, and we can look at temperature failures in data as well. Other problem is the O-rings for the bulkhead connector. You can see here, there's no O-ring, and then you can see it right here. There's a little black O-ring that's seated. There's actually 2. There's a second O-ring inside the bulkhead connector on this side. But that one usually doesn't fall out because you're not usually tipping over the transducer. But this cable one will fall out sometimes when you're putting it in and you're not paying attention. So that's why there's a sight hole. So you can always triple check you have an O-ring installed. Other ways to diagnose faults is the fault logs, the PT tests, cable resistance checks, when to disconnect the deck unit, check the deck unit itself, and then FFTs and data reviews. So we'll go through all of those. Fault logs is just 3 quick commands. There's not a lot of faults, but one of the faults does show over voltage of the transducer, and that means the transducer is dead. You can actually see that in the variable leader talked about one time. So we can look at the data and say, this thing's dead. Let's just start working to swap it out. You can clear it. You have to set the time on the deck unit, but most people don't use it. As long as you clear it once in a while, every time you start and port, like a new, when you're out of dry dock or something, just LC, LL, LD. Running a PT test. How do you, there's 3 tests that we run, and we look for failures in each of them. The PT0 would tell you the 3 different tests, or what are the tests you can run? It's PT3, PT6, and PT5. But if you want to repeat these 2 and just type 1, and you can type PT200. And this is in the in UHDAS, that if you want to just do the diagnostics, it'll run PT200. So, and it'll save it. Do you have it? Does it save it on your log file? So the PT3 is and the PT6 are both receive tests. They're looking for electrical noise. They're not putting any noise out, so it's not going to be damage your transducer. But what you see is the lags, the correlation doesn't drop, and it should be dropped from here to once it's at lag 5, it should be down to almost 0. If it doesn't drop, then there's a failure. The other, on the PT6, the second test, it should be 20% plus or minus of the expected noise. And you can see we're pretty low here on beam 2. So we're getting noise on beam 2 and then some on beam 3, but mostly on beam 2. So if we run the PT200 test and we see the noise, or we see it, then we know something's gone wrong. Or then the PT5 test is a transmit test, and you're not in water, don't ever run that. And so when you type PT5, it asks you, is this in water? Okay, well, say yes. This comes to our biggest point, is cable resistance check, so we can tell what crystal run.
That was like twice as fast as I expected, but nicely done. Maybe Sarah will get stuck after all.
Hey, so my name's Chris, and I've been an electronic tech for a long time. And I'm just kind of recently moved over to the ocean type business, so I don't have any oceanography science. So when people come to me with like data issues, I'm typically, give me like the hardware type failures, what's going on. So typically I will ask you, if you say you're having problems with your ocean spare, I'll want to see your cable resistance check, because this makes the most sense to me. So we have the cable resistance test. There's a dry side test, a wet side test, and they're going through the bulkhead connector. You could also do an end-to-end test. That's not really recommended. That'd be a pain. If you want to make your own type of test cable, you would use like a 1 millimeter female or male pin in order to do so. These are handy for when testing for sure. And we do have some examples over here. Yeah, this, if you wire it correctly, you can have it go directly to your multimeter, which make life much easier for you. All right, so when using multimeter, our manual says when measuring the resistance in a phased array transducer, it's important to understand the multimeters interpret high resistance values. Resistance greater than 2 megohms. Many multimeters will display an open or OL overload. I love this about our manual because it says in most cases this is not a fault. It's typically considered a pass. But seriously, how are you going to know what it is? So I recommend that you use like a meter that has at least up to 20 megohms. I personally recommend like the Fluke 115 and 117 models. I've been using those for years, and they're very reliable. And they offer a range of resolution between 40 megohms to 0.01 megohm, which is more than adequate for accurate resistances. I actually had somebody send a resistance check not long ago with one of these like lower meters, and I couldn't really tell anything about the resistance check because everything was open. And to me, that's like, uh-oh, I mean, when is it ever an open good, right? So that leads to the transducer dry resistance check. This is the actual wiring diagram. This is what the wet end to the transducer portion looks like, and this will be the dry side. I made this little cheat sheet for whenever I'm terminating these. So these pins right here are actually not connected to anything. They're not used. So it's kind of just good to know.
Can I clarify something?
Sure.
So when we say wet side and dry side means at the deck unit end,
Yes.
and wet side means down near the transducer end. It doesn't say
Right.
ADCP
Yeah.
side or cable side. but
It's
it
a
says
different
top
type of.
side or bottom side.
This is the dry side, this would be the wet side.
Got it.
Now, one thing that's important about this cable is we can only replace one portion of this cable. We can only replace the dry side. We cannot replace the wet end side of this cable. So if it gets cut, nicked, cut or anything, it can flood the actual transducer and flood the cable. So it's important to know that we cannot replace this part. So if this is damaged, we have to replace the entire cable.
Doesn't hold it on. So the top side can be done with a person a day and a person who knows what they're doing and a kit, and epoxy and all that stuff. But the bottom side, you have to get already on the cable.
It's a fun job too.
Up from the bottom.
It's hard. I'll show you actual cable. But the actual cable, this guy here is made up of these twisted pairs. And I'll show you that in another slide. But the twisted pairs, as you can see here, are all part of the transmit and part of the receive. The center core here, which is, or again, I'll show you on the slide, but it's kind of like these little wires that are not the part of the twisted pair. They're going to be your power, your synchro, which is something not really used anymore. It's been phased out. Your temperature sensor, and there is a ground here, which don't need to worry too much about. But when working with phased array transducers, it's important to recognize that all your twisted pairs here and all they're part of your phased array transducer, I'm sorry, is part of a reciprocal pair. So that means like
The transmit goes down and then back up.
Right. That means, whenever you're making your measurements for your readings are all going to look somewhat alike. They're not going to be that different. This is one I just recently took in Singapore. So you can tell everything is kind of the same, which is important because, it kind of mirrors each other and duplicates everything. So mismatched readings will typically be a strong indicator of you either have some sort of component failure or your beamformer board could be damaged, or there could be corrosion in the system, or just some overall system failure. And this is kind of expands on that. Whenever you're actually doing a resistance check, this top portion will be your transmit twisted pairs. And you have the 4 measurements. Then you have the receive portion. You have the receive twisted pair shielding. You have the beamformer, which is actually your diode check also. The temperature sensor, power. This portion here is not really used anymore. I don't really know if anybody will see that in field. And you have your grounding here, which is your twisted pair shielding. And this is what it all looks like kind of close up. You have your twisted pairs, you have your center core. Then the twisted pair actually has an interconductor shielding. There's 2 of them here. You'll notice here that there's like the shielding around the actual rubber portion of the cable that protects it. Then there's this hard inner shielding, and there's a ground that's part of that as well, along with your twisted pairs and your center core. Really fun system to have to terminate. Anyway. So the diode test. Whenever you're using your meter, you need to make sure you're using the actual diode portion of this. To ensure the diode positioning is select on voltmeter. Well, ensure the diode position is select on voltmeter. That's the symbol right there. So whenever you perform this test, you need to use both direct and reverse polarity. The reverse polarity is connect the positive to U and the negative end to T. The expected reading will be around 0.6 volts or 0 L. I'm not 100% sure about this reading myself. I think the manual might be incorrect because I have never got the 0.6 volts. I always get like 600 kilovolts or something like that. So This reading here, we're not overly worried about. So the actual forward polarity that we're actually looking at the most is where you connect a negative lead to U and a positive lead to T. And since this is a CNR diode, the expected reading is going to be around 1.9 volts. And it's not going to be 0 volts as with standard diodes. This is kind of like the check that we're looking at because this verifies that your diode's actually working. Yep, okay. And again, this is what the actual resistance check looks like whenever you're completing it. You notice that everything looks kind of the same. It's nothing's crazy off sync here. You have your receive enable check here. And this one's actually important to know because it's either going to be 4.75 or 99 kilo ohms. Don't worry too much if that's kind of out of whack. If it's like 105 or so, that's fine. You want something close to the ballpark. It doesn't have to be exact. Then you also have your temperature, your diode check here, which is, I got like 651.8 K. But as I said, the second reading of 1.604 volts DC is kind of more what we're looking for.
It's 0.6, so it's just the units.
Yeah, it could be. I just have meter incorrect there. So also we have the ground here. I typically always get open on this. And this portion here where it says 20 mega ohms, it's typically also open. All right, these are actual notes as part of this check. I'm just putting it here for reference. And this is an example of a bad reading here. Like I said, you have an open here, which would be an indication that your beam 1 for transmitting on the beamformer board, there's probably something damaged with it. As the same with beam 3 here, is only 6 ohms. That's kind of suspect when it should be actually mega ohms. So that's one thing to just keep in mind. Same with these are all kind of like the same, except for it's 13.5 mega ohms. And again, that's a sign that something's going on. It could be corrosion. Something could happen to the cable. Just things to look out for. And it's just all troubleshooting tips and things that will help you troubleshoot what's going on with your system. And then we have the receive enable ground here, where you're supposed to have either 4.75 or 99 kilo ohms, and now we got like 70 mega ohms. There's definitely something not going on. Not happy with this system there. You're probably lucky to have power. And then we look at our diode check, at which point is open, which can be fine, but the 0.20 volts DC, that's way low. So again, you probably don't have power at this system. So it's all just little things to look at. And I think this is really beneficial and will really help you is whenever we do an install, we will provide you these checks. So you will have like a golden standard of how your system was when it was installed. And over the years and time, you can actually do this cable resistance check and will help you see how your system's aging and, possibly give you some indication of what's going on with it. If something's starting to fail, you have a beam starting to go, and you can probably see it slowly degrade over time, which is give you a heads up on what you need to do to correct your system. And there is another check on this. It's the wet end resistance check where you actually connect to the transducer end and you measure to the deck box. But I don't really recommend that check because it's much easier to just unplug the transducer and do your bit test on the deck box itself. That way you can just test the deck box. And I had somebody actually send the readings for the deck box, and I've taken it myself, and sometimes it just doesn't make a lot of sense, and we don't have a whole lot to really compare it to. So it's not really helpful. And things to look out for with your connector. You can tell this one is in all kinds of problems. I mean, you have corrosion inside of it, which means at one point the O-ring failed and it leaked. You can see here where something scored and it shorted out of the system. So I think there's actually a pin that's melted into the connector. So just do visual checks whenever you look on things. It's typically, as he told me in the Navy, keep it simple, stupid. So that's how I troubleshoot it. It's just visual and one step at a time. So, things to look out for are corrosion and evidence of flooding, scorched pins or scorch marks on the connector plug, cuts, abrasions on the wet end of the cable. They may lead to flooding. Keep an eye out for cable fatigue or excessive cable wear and crushed cable. All pretty simple stuff. And that leads to this one.
So when to disconnect the deck unit and run the PT tests. We run the PT 200 test, we'll run all of them, and if you're getting failures when the whole system's connected, we wanna disconnect the deck box from it, because and if all your cable resistance checks look good, then most likely the deck box is suspect. So we want to run the the PT tests on the deck box. If the PT test fails, you probably got a bad deck box. There's a bunch of tests we can do on the deck box, but if you want a quicker test check and we can send you a deck box, then you can install it and test and see if it's working or not. We have some, and the the SIO UNOLS pool has some that they can share. When you run the other test you can do is you run the PC2 test, and if you don't see any temperature data coming out, that's another sign that the deck box has failed. If we're looking at just the raw intensity and correlation data that's shows on one beam, that's a sign that the deck box has failed. So we want to run all these tests again. Another test we do is FFT, where we can provide the software and you can look for interference. FFT, fast Fourier transform. We're looking at the beam signal on each beam on each beam pattern, and we're looking at the sines and cosines to make FFT, and we're getting a spike here. So this spike is right in our noise range, and it's about 10 decibels over.
So UHDAS doesn't do that. We can't do that. If you're gonna do a test like this, you break out a Windows machine and he'll give you a Windows program, and that's the only way to do this.
It's kind of a last resort. We kind of know something's wrong with the system if we're getting this far, and we can do it. But most of the time, we're obviously already, it's time to pull the transducer or swap the cable at that point. This would be this would be your beam pattern for a nice clean one, clean FFT. You can see beams 1, 2, 3, 4, but on beam 2, you're getting a big spike, and that's causing interference on our system. That's 10 decibels above our normal pattern. And you can see it's happening on beam 2, 3, and 1, tiny bit. So we're either getting noise into the cable, or so it's exactly going back on beam 2 only, the signal. But most likely there's EMI on the cable. Joules and UHDAS has a big repository of other things that look bad in data for single ping data that we can look at. If you guys want to look at it yourself, or you want us to look at it, we've added the links up here. You can look at stuff for days and days. Another thing that Joules figured out is if the temperature is pegged at 92.56 C, your electronics are and the transducer is dead. So, and if you start to seeing spikes in the noise, you'll see this you can see this, not on the shipboard.
Yes,
Okay, on the shipboard.
it's the OS temperature.
Yeah.
I think we have I know we see a diagnostic plot. I think there's a diagnostic plot on the newer installations on the website. We're putting more and more diagnostic plots in there, but be sure we'll let you know within a day.
Do you have that time series plot on the chip display?
With the temperature?
Yeah.
I think it's in the newer ones, but we're lagging in getting that rolled out.
Okay. Because of the thermistor is embedded into the transducer through the bronze into the ceramic braid. That's why you can tell
Right
there's some.
beneath the bulkhead connector.
Yeah, I showed a picture. It goes right through the beamformer, right into the heart of the transducer, the ceramic. So if your ceramic is flooded, then that's why you get the grade 92.56 C, because that's max for the thermistor. You get an occasional temperature spike, it's probably coming from something else, or you're getting EMI on the cable. It's not usually that common, but it's an issue. So we're gonna have to get there.
We want to talk about that newer failure with the ceramics, so like being paired correlation. It's a certain.
I was gonna bring that up.
Can I don't have any slides.
I don't
Well, that's all right, but the manufacturer, the way that the ceramics work, 1 and 3 are correlated, right? And 2 and 4 are correlated, so one particular kind of error has a pair of them going out.
Yes, so because it's, well,
Well, that's why you said if one goes out, it's more likely to be the deck unit.
yeah, one goes out, it's more likely to be the deck unit, but we don't have,
I don't think we have any plots.
so we,
Making a list of all the plots we're gonna provide.
because it's the beam, the phased array transducer is like it's a waffle shape, and there's like I don't know, 100,
280. I don't know
280.
where it is.
Well, in little ceramics, they all ping separately differently, and they make all the pings at once. It's one ping that goes off, and it makes 4 different beams. So this direction and this direction are paired together. So if you have a failure, usually if you have a ceramic failure, you get these 2 beams failing at the same time, or these 2 beams failing at the same time, not just one beam failing. If it's one beam, it's most likely not the ceramics, usually the cable or the deck box or the bulkhead connector. If you have 2, it's usually the ceramic.
And what we've been seeing with that failure is it's not necessarily like the RSSI, like the intensity return that's, you can really see the failure on the 2 beams. It's on the correlation data, these 2 beams that are both failing are like very well correlated and differently correlated compared to the good 2 beams. So it's more checking the correlation data rather than the intensity or the return data on that.
Do I get to ask another ocean surveyor question?
Yeah,
Okay, so some ship, I don't remember which one, I could make it up. But some ship got a new Ocean Surveyor 150 and it had 3 stripes like that. And they're like, we just sent back a dead one and we got this new one. It's got these stripes. What's with that? And the answer was, oh, that's normal. Now, from my recollection, it worked fine. So,
I don't know.
so in your experience, if somebody returns a dead instrument with stripes, you're like, oh, those 2 beams are probably busted.
Well, they're electronic traces across that. And we don't actually not making using clear urethane anymore. So you wouldn't be able to see it. It's only the orange urethane.
Okay, okay.
Now.
I just saw a new system in Singapore, you see the traces on that 150.
Yeah,
So, I think they did change it to the urethane at one point. That wasn't like an older unit, but it was brand new, it hadn't been used.
because the 38s never had the clear,
No.
urethane.
Right.
Everything's switching over to the orange urethane, and it's a lot of the changes in urethane and rubber are all to remove hazardous materials from our facility.
Ah.
Right.
Okay.
Because on the on the workhorse connectors have changed and all the rubber, everything's softer because we've removed lead from everything.
Oh, interesting.
Yeah, it sucks.
So maybe we do get some workforce.
Yes.
Okay, glad you had time to practice.
For correlation, it's more, you're looking at the data. That's one of the 2 things you're looking at. Where is that slide? Here. So we use intensity and correlation is kind of like, those are the strength of the return going out is the intensity. The correlation is, say you have 4 pings going out and you want 4 pings coming back, and you have to look at, well, do they line right up and how clean are they? That would be the simplest version of correlation I can come up with. And so that's data side, not really instrument level.
But then it's the ceramics and not field
Yeah.
replaceable. So my name's Sarah, and my background before coming to RDI about a year and a half ago was more in coastal physical oceanography. So I worked mainly with workhorses, not as much the vessel mounted stuff. So we're gonna go over kind of what a workhorse looks like and where different failures can get in. It does echo the ocean surveyor in some ways, but there's a couple slight differences. So we now have a piston array, so it has 4 separate beams, unlike that phased array. And we see more with the piston arrays is you can get some of this peeling on the transducer, and your signal will at first look fine, but as soon as we see any peeling like that, you're gonna wanna remove that system because that can lead to water ingress through the ceramics into the electronics. So that is a common mode of flooding and failure in the workhorses that you need to be aware of. So we have a workhorse 1 and a workhorse 2, and the electronics are slightly different. They have all the same, bits and pieces, but kind of the location of them are going to be a little bit different. So this is going to be our original workhorse 1 board stack with kind of some main points here. We're really only going to touch on in this, since I kind of tried to condense this down into 5 minutes. We're really only going to focus on this RS-232 422 switch. So I'll kind of hammer down on that a little bit later. So that's the original workhorse board stack. And then the workhorse 2 board stack is going to look, has this different, it's going to have a different compass in it and just have, I think it only has 2 boards relative to the 3 that were in the previous old workhorse. So those are just the differences between those. And then
the compass is only relevant to board instruments. We don't use that in the board.
Yeah. So similar to the Ocean Surveyor, you're going to have these PT commands. These can be run, another difference because of the piston array, they can be run in air. So you don't have to be worried about running them in water or blowing the system by accidentally pinging in air. So very similar to the Ocean Surveyors, kind of what we're looking at there. I'm not really, since we already talked about that, I'm not going to go into too much detail. Again, we can check the fault logs. We can do FFT. So this is a newer software. I don't think it's on the software portal right now, but if we need to do an FFT, we can send it to you and we can do a PD0 check. Kind of, we'll get some variable leader errors if there's any errors. We can also run an FFT in it as well, which is really nice. So this is just an example of what, a fault log would look like. You can run this, and I don't know if you guys have ever used Toolsy. It's just kind of a nice, easy interface to use. But if you're having any issues, we'll send you Toolsy, and then we can also send you this newer software, ADCP utilities, to run the FFT. So I mentioned we're going to talk about these 232, 422 switches. So now we're getting into kind of some comms issues. If you're getting, garbled data or no data, you can open it up and you can make sure these switches are flipped to the right side. I think most of the ones in vessel mounts are in 422 because you can have that longer cable. So you just want to make sure it's on the right side. It can sometimes in transport or even just in the ship get jostled and get stuck in between the 422 and the 232. So that can lead to some comms errors. So that's kind of my first pass check. If there's any issues, it's kind of cable resistance, loop back, which I'll talk about in a bit, and then checking and making sure that switch is in the right position. So now the loop back test. So this is all laid out in the manual. So I'm not going to read through this, but essentially you're just making sure that you're getting repeated characters back and that your cable has that comms connection that's working appropriately. And there is a difference between the 232 and the 422. But again, this is all very nicely laid out in our manual, so I'm not going to read you the manual. Here is our pinout for our cables. So I have, it's kind of blocking in the top there, but in the top there, I have like monitor and then the Mariner, which has a different pinout there. So the cable is both power and comm. So you can see that in the pinout that we have the power on the bottom and then the comms return on the top, depending whether you're using 422 or 232. So the deck unit, if there's any issues with the deck unit, the first pass is to check fuses. There's 3 fuses. Again, the manual goes through the details of where those are all laid out, but those would be the first check is the fuses and then the pinout again. So just checking that you're getting your comms and your power through that. So our bench top cable is very notorious for having a lot of EMI and electrical interference. So when installing, whether it's bench top or any cable, just be very careful. So this is an example of a situation where they had a little bit of electrical interference based on where it was mounted, and then just shifting that cable down so it's not attached from that other power supply, it got rid of that electrical interference. So just being really careful when you're installing the cable that you're securing it in a place where it's not going to have any interference with any other power sources.
Can I say something?
Yeah.
Yeah. Just to make that point, typically on a ship, you've got the deck unit, which is just a really high quality power supply, along with some inputs and some outputs. We basically just use it as RS-422 serial in and power supply. If you decide to use your own power supply in order to use RS-232 so you can trigger the instrument, that's the kind of time when you might be tempted to use a crappy power supply. Don't do it. And the easiest crappy power supply you can get your hands on is the one that came with the instrument. Really don't do it. That's how you get all this EMI that's in. So there's a distinction between introducing EMI through the cable and introducing EMI through a bad power supply.
Thank you. Yeah. Yeah, I had a case recently where it was our benchtop's power supply, and there's like the power box and then a cord that plugs into that and then plugs into the wall or whatever power supply they were using, and that was bad.
The cable was crappy.
The cable from that box that goes into the wall was bad.
Yeah.
So it just induces multiple failure points that are it can be a little dicey. So take over.
Okay, yeah, so when to contact us?
Well,
I mean, you can do whatever you want. Did Jules or Andrew contact you guys first and say something's wrong? Sometimes Sarah and Chris and I, we like looking at data, shipboard data. We look at it all the time. We were looking at the Revell data yesterday.
Yeah.
It's pretty cool, all the undercurrent stuff. So we like current data, so we geek out on that. When to contact concerning failures, what's the failures? If you find something else, that's if they've contacted you, then email us at RDIFS. What to send? Not everyone has the serial numbers of their transducers because, well, you weren't there when they installed, or
It's printed on the thing at the bottom and you can't read it when it's.
yeah, and that usually comes off in the transducer well, and yeah, so if you have the serial number, great, that's even better. What frequency? So that's just,
Yeah, typically what'll happen is that if it's a gas install, we get the data, we get a snippet and a bunch of things we can look at, and we look at that once a day. Somebody in our group, 365, looks at that, and about once a week it's me, and once a week it's somebody else on Saturday, and then the rest of the week it's somebody else rotating. And we'll catch something within a day or a week, and we'll see that there's a problem. We'll probably log into the ship and grab data from the last week or day, or the first file of every day for the last year, or something to try to diagnose what the problem might be or what went wrong. And essentially we'll point it out to you and we'll say, can we contact RDI? Because basically it's like, I can boil water, but I can't make a meal. So we'll find the stuff and then hand it off, and you're talking with them about the actual problem and how to deal with it. That's why I don't know anything about those diode tests, because that's them helping you through that.
and so sometimes, depending on the cruise, you have to get approval from the chief scientist or UHTAS to send us the raw data. So you have to do that, and that's our bathroom. And raw data, if we like to look at raw data, good and bad, to see if something's easier. Well, this happened on this date. You guys weren't doing anything on that date. Great. That's so we can look at the raw data, the beam velocities, the signal return correlation. But if you're you're on the ship and you're gonna send us stuff, we want to see your log files for your PT tests, the cable checks, and if we get to the FFT, or if not, pictures. Like you guys are on the ship, have pictures, say 1,000 words, and just overload our 500 gigabytes of email that we get all the time, and pictures.
So we
troubleshoot.
diagnose problems with a combination of single ping raw information and processed data. So that picture he showed up at the beginning with the electrical noise that showed up with the red and the blue feet. We can catch things like that. So we look at these different things. If you have a question, if you have a UHDAS installation and you have a question about something and say, this looks like a something problem, what do you see? Shoot us a question. We'll let you know whether that's a known problem or an unknown problem, or, I mean, you're the ones on the ship, you'll see it. But it also may be something that we know about and can't do anything about. oh yeah, your instrument always goes like this when you're in your data always goes like this when you're in the ice,
Or where there's no scatterers.
or where there's no scatterers, yeah, that's
Yeah,
right.
so, you know, we don't want to hear from you guys. We'd rather that everything works. We don't want to hear from Jules because we like Jules. But we want you guys to be, you know, want your instruments to be working and we'll work with you and, you know, like we have demo 150s to plug the gaps. If you need a hole to get stuff in, we'll do cable, help you do all the cable checks. We'll send out deck boxes. Everything we can to keep you guys getting good data. All right.
Yeah, this is I haven't written it up. But after talking with these guys and after having several failures in the last, I don't know, 6 months or something, I've now graduated to the cable pinout. And so it's like, yeah, you gotta do that. I'm not gonna deny that diagnosis exists. I'm gonna say, please learn how to do it. And so, you know, instead of just running the PT tests, I'll say, can you also clean up the cable? Because otherwise I'm dumping it on them first. And the first thing they're gonna say is run that test, so. You know, the cables, they can take you through the details of whether to do it with the deck unit, with the cable unplugged or not, and additional ways of running it, but just simply turning off the deck unit, unplugging it and pinning it out, owning it out, and then writing up that form. Everybody should know how to do that, except for me. And I should know that you know how to do it. And then that's the thing about SOPs, is that it would be nice to have these things be run on some regular basis and keep the records of what you've got.
And also make sure you have the correct multimeter that can do it.
Yes, oh, and regarding flukes, when I got married a lot of years ago, a lot of years ago, we didn't have a registry, but we had a gift list. And so we got a Baby Mac hamburger fryer. You know, there's a lot of stuff you get like that that's stupid. We had 2 electric screwdrivers. And my husband put a fluke on there and his boss gave him a fluke 70 and it still works.
Yeah.
Utterly reliable. Oh, but who has questions? This is so amazing. Congratulations, guys.
Well,
2 minutes.
we have all the links. This is they're gonna post this. We have all the links, all our manuals, everything's online. The quickest way to contact us is adcp.com. It's on the way, you know, that's it. All the manuals there, you can see it all on your phone. Just click on there, do a quick search. You know, that works. So this is our support team, all of us in Poway. And this is all your UH staff team. Any questions?
So, on our particular installation, the wet end is dry, right?
Mhm.
I don't know if that's unusual, is it?
It's relatively unusual.
So like when we have UH DAS problems, and the first thing I say is do the pinouts and do your resistance, and like, we know it's not the cable, like people aren't allowed.
Well, sometimes people install it with too tight of a bend radius, so it just
Yep.
wears over time, or it's not secured somewhere, or it's running next to 680 volts. And sometimes when they turn on the valve thruster, you're getting a signal just, so usually it's not the cable, but
Or
yeah.
somebody went down into the well and it was a big well and a dry well and they were gonna paint it and they stood on the cable.
And on the reverse of that, if it's a huge well, and if it's a wet well, like they can't get all air bubbles out, then the well sloshes around and the cable's not secured, then it could get damaged. Because the potting, like, this potted part's not meant to be worn out. Vibrated that every 8 seconds you take a wave sometimes, and it's going back and forth, so it's not really meant for wear and tear.
And also kind of related to that, because our wet end is dry, the 2 times I've seen an OS 75 failure, there was also seawater intrusion into the beamformer from the wet side of the transducer.
Yeah.
I don't know if that's something that you see.
You had
It's like chicken
your
and egg.
fail there.
Did that cause the failure, or was that
No, probably
related
not.
to the failure?
I would imagine probably not, because they're separated by like that much. So I would imagine a beamformer failure would either be spontaneous or from the top. or the
Well,
ceramics.
it's an element failure, but then seawater works its way through.
Yeah,
It's like a
so-
little tiny hole with like epoxy in there, and then some seawater gets through there.
It goes, if the beamformer is wet, then that's flooded up through the thermistor. So the whole ceramic array was damaged. And we saw it one time where on the oleander, where was it the boat?
Oh,
But it
that was the
exploded.
only, that was the oleander. It was like somebody took a biscuit cutter on the window and went around 3/4 of the way around the outside of the polyurethane and it flapped out.
But the inside, the
ceramic was-
capacitors on the beamformer, it exploded also.
Oh, yeah, that's right.
It was,
slammed
it was like nothing anybody had ever seen. Yeah, it was, wave. There was a huge storm and they just must have taken the perfect wave where, cause it's, the transducer well is basically just a drum. So it must have just gotten the perfect wave and it just boom, and exploded
And it's
everything.
way far forward. Container ship.
If you guys do have transducer wells, I have a question. Do you guys ever flush them? Or do you just leave it as is until you get back to the dry dock? Because I've seen some like weird growth, and at least someone in Taiwan where they had mold growing inside the transducer well. So I don't know, it might be good.
Some
to-
of them have vents that they could flush them, but they're working, don't.
I think usually if there's a window, it's either got fresh water in it, if it's mid latitude, or if it's polar, it's got propylene that's all.
It's not funny, they do have vents below on the wet side that you can pump water through or degas, like vent it out.
Okay,
Some wells do, some
If
don't.
you do have a well, if you do have a window, make sure that there's a bleed valve that goes up high, so that if there are air bubbles, they can actually get out. If you have it completely sealed and you have air in there, you can't do anything about it. But if there's a bleed valve, that's just a tube that goes up. It's best if it's like, I guess probably plastic up at the water line, and then you can actually sight it, you can see. So, you're standing here and this is the water line outside and then down 2 decks and up 2 decks. You can see that the water pressure is at where it's supposed to be, and if it's less than that, then you should top it off.
I don't think there's very many that have that long of a lead line. There's some that are just like this high, most of them are, and most of them are just short with the valves and. As long as you get the air out, you leave the air inside on the face of the transducer, especially the 38s, they'll die. Right, because it's trying to transmit all this energy and it's reverberating back and forth in that air bubble. It's not being able to expand that, the pressure wave it's making, and it's just gonna bounce back and kill it.
if you're in a dry dock, by the way, and we're not there to assist you, one trick you can use is to use like Dawn dish soap. You put it against the face of the transducer, and that way, when you put your window back and you fill it, that
There,
air will bubble off along with soap. And it causes to be smaller bubbles and. it's
right,
easier.
there's also a lot of people who use anti-fouling paint in their window. That's another valid scenario.
One thing I've seen, that I'm kind of curious about is if we know what sort of lasting effects on the transducer itself would result from plugging in the incorrect deck unit.
If you plug in the 150 deck unit to the 38, you're not gonna have a problem. If you plug in the 38 deck unit to the 150 and you run it, you're gonna use the transducer as a fuse somewhere in there. I've seen
Different
it.
capacitors. and-
Yeah, they put on the Palmer, in a shipyard in Tukwona, they plugged the 38 because they're exactly the same. So
Yeah, we don't label it on the front very well.
also the same shape, and I mean, the most of that connector is the same, so
It's the same deck box, same connector.
freaking good labels.
Yep.
So they use the 38 kilohertz deck unit cable on the NB narrowband 150. And the Brazilian Navy had this thing that you could plug a board in and climb around on the bus inside of it and find the bad component. And they found another component and soldered it in there. That's because that instrument in narrowband 150 was so old. It had like hand soldered stuff. It didn't have one of these surface soldered things. But yeah, you're shit out of luck if you do that. I mean, I think anytime you have a smaller frequency driving a bigger transducer, you're just gonna get weak data. And if
Yeah,
you have a
yeah.
bigger transducer driving a smaller one, you're gonna blow it up.
Yeah.
It's the size of the capacitors putting the power into the
Yeah.
array. It's not meant for that. But
True.
Yeah, I have a question. Actually, I have a question about the PT5 test, aka the transmit test. To me, the output is basically just a matrix of like zeros and 255s.
Yeah.
And I was wondering, yeah, first of all, what is happening, when you run that test? And second, how do I look at that data and interpret different error states?
I don't know if I could give you a well enough explanation. You know, it's putting out four pings. The 255 is the correlation, right?
Oh.
Because that's perfect correlation. So it's putting out a ping, 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 like four correlations. So you'll see a little bit of noise in the 0, 0, 0, 0, 255, 255, 255. So once you start seeing noise between that, then you know it's not putting out a proper correlated ping. And some instruments it doesn't, they don't, the PT5 is not an acceptable test on some of our other ADCPs, but for the OS and the workforce. I think the workforce too is going away, right?
Yeah, I think it might be, but I think
Yeah.
for the original workforces, it's still.
Yeah,
viable
so
test.
it's basically you're looking for the correlation. And then there's no correlation, and then there's perfect correlation. If you have if you have noise and then bad correlation on those four, then then it's not probably the beams where we're not making something right, or the ceramic not making something.
Okay.
So in our documentation, there's a section near the end that's got, I would say a large number of figures showing different categories of things where you can recognize it in either the process data or the raw data. And this one here that he's got, that one right there, that is an even larger collection of different kinds of errors that you can see in the single pane. So on the UHDAS display, somewhere in the website, somewhere down on the left, towards the bottom, it says diagnostics, and there's one that says beam velocities and beam amplitudes, and that's where you can see these exact things. So we get a little snippet and a hint, and we don't have that website, but we go out and get a couple 2-hour files and make those pictures. And I've got my entire desktop is full of screenshots of things that I've labeled and sent to people. And I've got lots and lots of pictures that I would like to take the time to annotate and categorize. So somebody could just say, either by symptom or by cause. And then just, look at all the different examples. Does mine look like this? I'll get there someday.
Also, if you're running like the PT3 and the PT6 tests, run it multiple times and log the results, because I've seen some intermittent issues where it goes away, comes back. Oh, there it's gone. So if you only do it only once, you might miss what the actual issue is. Could be something else.
In
Yeah.
the same vein as that, sometimes if you run those tests, you can get like environmental noise, so it looks bad, but it might not be. So that's another reason to run it, is maybe that first time it looks noisy, but maybe there is something running in the background that caused it to be noisy. So running it multiple times kind of gives us a better sense of like the average of those tests.
Yeah, another example of that would be, are you in port? Are you underway? Are you on station? Do you have a valve thruster running? Because a lot of these tests are going to look, not the electronics ones, but the ones that include ping will look different.
So I found noise on a cable one time where the deck, it was the same layout, but when we had put the cable through the same path, we're picking up noise from some other cable that was up in the rack. And the only way I figured it out was pulling the cable back, running PT test, pulling it back, going to the next room,
Oh,
and then
geez.
said, "Oh, we're
room.
back in the kitchen. I mean, there's no noise here." And so then I had to run the cable all the way, keep doing that all the way back to deck below, cut the cable, re-terminate the cable down there. And then they still ended up having problems from the valve thruster because we weren't running the valve thruster in port. So we had noise on. So there's not we're
Yeah, we should probably put so people can go to the next
okay.
workout session. Thanks for coming. You know where to find us all.
Stop. Stephanie, should I stop it?
Be sure to grab some flag if you haven't already.